All right, let's look at a different function. How about it? I'm tired of tangent. Let's do something different. Let's talk about cotangent. Cotangent is the reciprocal of tangent, meaning instead of being y over x, it's going to be x over y. So what I have here is a picture of cotangent. You'll notice its period is pi, which means every n pi you have a new asymptote. So the math is going to turn out to be the same, other than we will just have a different ratio in step one. So here we go. Ratio, step one. Not ration, ratio. There we go. Ratio for cotangent. Sine is y, cosine's x, tangent is y over x, cotangent is x over y. So if I needed to find a vertical asymptote, I need to look for when y equals 0 now. I want to find out when y equals 0. So let's go on to step 2. Step 2, the way I've been doing it is I've been using the unit circle as my reference, and I want to find out when y equals 0. So this time I have a different value. So I'm now looking at y's, and I just look in the first quadrant. That'll help me out to get the value I want. I see y is 0 right here. I'm going to choose the easiest number. So technically I could use 0, I could use pi, I could use 2 pi. I like 0. It's a very simple number. So I'm going to take 0. And so we're not confused here. It's 0, and that is in radians. So y equals 0 at 0 radians, if you want to write that out. You don't have to, but it's at 0 radians, just so you know that I'm talking about an angle there. Okay, so step 3. Now I apply my horizontal transformations. So here's what I know. I'm starting with a asymptote at 0 without a transformation. And these occur every n pi because, again, that's the period. It's 1 pi, so it'd be plus n pi. But I have transformations. I check up here. What is occurring horizontally with the x? What's that 2 doing?
Multiplying.
Multiplying. What's the opposite of multiplication?
Division.
So I'm going to divide everything by 2. That's the opposite. Now, dividing, you go all the way through. So what do I left with? I have 0 over 2 plus n pi over 2. And I can just simplify all that and just say x equals n pi divided by 2, where n is integer. So that little double z thing, where n is any integer. So we'd have an asymptote at 0. Let me get my colors going here. They did not include this one. You'd have one at 0. You would have one at, this is when n equals 0. All that cancels out. So when n equals 1, you would have one at 1 pi over 2. That's 1 pi over 2. And then when n equals 2, you would have one at 2 pi divided by 2, which is simply 1 pi. So that right there is 1 pi. 1 pi, that's pi over 2. And if I wanted to do this, list this one out, this would be -1. This would be when x equals -1 times pi over 2. That would be the location of that asymptote right there. So now that you've seen that, you ready for it? DOL number 3. Go ahead and try this problem.